talk about Dart annotations in depth, Behind the At by Anna. And if you don't know who Anna is the one always bringing chocolate to conferences. That's the only thing you need to know about her. Please go ahead, Anna.
All right, so if you spend some time doing Flutter development before, chances are you've seen a warning like this. Here we have a widget with a build method, and it produces a warning because it's missing the override annotation. And how many of you have ignored a warning like this after upgrading Flutter in your project? Over time, some APIs get outdated, and they are marked with the deprecated annotation to make us stop using them. So we are interacting with annotations like override and deprecated quite a lot in our daily Flutter development. They trigger analyzer warnings and are used by library and framework authors to communicate the correct ways of using their API. And our bare responsibility as Flutter developers is to comply with those guidelines. However, it will make us even better developers if we learn to apply these techniques in our own code. It doesn't matter how big your project is or how big is the team working on it. If you're going to maintain it for some substantial amount of time, even if you are a single developer, annotations can be a great way to provide technical documentation for the code right inside the code base and communicate the intention of how it was supposed to be used. Of course, documentation can be written somewhere outside of the code base. It can list all the best practices, naming conventions, architectural principles of the project. But it's most efficient when it is built into the code, issuing analyzer warnings the moment something is off. That's way better than relying on CI checks that run after the code is written or waiting for someone to call it out during the PR review if it gets caught at all. So today I'd like to talk all about annotations. Before we continue, I do something more than just bring chocolate to Lucas. I'm Anna, Dart and Flutter GD from Ukraine. I'm passionate about technical excellence and quality and about sharing my experience online. So I'm currently leading the client platform team in a UK fintech company called Tide, where we develop financial platform and associated services for small and medium businesses across the world. And we write our mobile applications with Flutter. So let's start by reviewing what built-in annotations are available out of the box, which you can leverage in your code base. I'll start with the most basic one, override. Here we have a classic object-oriented example with an animal abstract class and a method called makeSound. And we have a child class cat that provides an implementation of the makeSound method. This code generates a warning because the member makeSound overrides an inherited member which isn't annotated with override. And this will be true for any case where a child declares the same member as the base class with the same name, but does not use an override annotation. This is done so that developers either explicitly say they want to replace the behavior of the superclass with the annotation, or they choose a different name and not confuse the users of this class. And this makes the codebase more error-prone. We use deprecated much less often in our own code bases, but mostly face the consequences of it being applied in libraries or frameworks we use. Authors use it to indicate that some API are getting deprecated and will be removed in the future versions, so we should stop using them as soon as possible. And we can apply the same principles in our own code base. In this example, we have a dinosaur marked with a deprecated annotation with an explanation, extinct reptile, and the makeSound method is annotated with a plain deprecated annotation. So below, when we try to instantiate a dinosaur, we see warnings that this code is deprecated and shouldn't be used. Next, here we have a base class animal marked with immutable annotation. That means that every subclass of animal must have only final fields. But in our case, class rabbit has a mutable field name, and thus we get this warning. It is another nice way for library authors or ourselves really to enforce the intended usage of the class and prevent mutability bugs. Here we have a base class animal with a method eat. It is annotated with must call super, which means that any subclass overriding this method must still call the base implementation. But in our class hamster, we have overwritten it without calling super. And if you check the implementation of the base class, you'll notice that it updates the internal object state, and without calling it, the hamster class implementation is buggy. So it's nice that animal class authors have a way to configure analyzer with must call super annotation to immediately warn us that we are violating some contract. Now imagine if our animals lived in some kind of environment or habitat. Here we have an abstract class called habitat with a list of animals and a class called earth that implements it, and we have a global final habitat instance. Now, we want animals list to be up to date with all the animals that gets created, but we don't want to pass habitat instance around all the time. So animals access it via that global variable and register themselves in the list. This code, as it is now, is hard to test. We all know that Earth is somewhat unpredictable environment, and in tests we'd like to replace it with something we can control. In real-world projects, a good example of such an environment would be a file system. But if we made this global variable non-final, it will open the floor for potential bugs. So what we can do instead is to transform it into a getter that would either return a given instance or instantiate the Earth class as a fallback. And we can mark this given instance with visible for testing annotation, so it can only be provided in tests. If accidentally some production code tries to override that habitat instance, it will produce analyzer warnings. Next, I prepared a few lesser-known annotations just to tickle your curiosity. UseResult can be used above methods, getters, or functions to force you to use the result of it returns. In this example, we have a class called chicken, and we have a destructive method called collectEggs that clears the list before returning. So it would be a real pity to lose all those eggs if the result of this method is not stored. So since I applied the UseResult annotation above collectEggs method, the code below produces a warning that the value should be stored. And there is an annotation called do not store, which has the opposite effect. Imagine there is a getter which is likely to return a different value every time it is called, just because the environment it talks to changes quickly and is very dynamic. Like, for example, animals' population size. So we wouldn't want someone to persist this number into a variable and make decisions based on that local copy, just because it immediately gets outdated. So by annotating this getter with do not store annotation, I can produce a warning when someone saves its value. It's quite a rare case, but still nice to know. And this list is not exhaustive, and you can even find more annotations available in meta package. It even still contains the required annotations that we used to apply on named parameters before it became a language keyword. Now, as someone who works with in a team with over 100 of Flutter developers on a project with millions lines of code, where it is impossible to track all the changes and review every PR, I always look for ways to automate code quality guards and minimize human errors. In a project of such a scale, there always are some custom agreements that cannot always be fully covered with just built-in annotations. However, you can create your own custom annotations, and first, let's explore what annotations really are. Override is just a constant instance of some empty private class. And thus, it offers a single usage, just using this constant instance. Deprecated is also a constant class with a single message field. Here we have deprecated with capital letter, which is a class name, and thus a constructor name, and deprecated with a small letter, which is an instance of this class. This here is also a good example of naming convention for annotations. Class name with capital letter, instance name with small letter. Really just a regular Dart code. So this instance can be used directly, just as the override annotation above the make sound method, or we can create different instances using the const constructor, providing a custom message, just as we have above the dinosaur class. The main point is to have a const class constructor and its instances as const, and that's it. Annotation is just a constant. So let's now create our custom annotation and see how it can serve as code documentation. As an example today, I will be demonstrating an annotation called must use const. Let me explain. In sizable projects, we may be relying on tree shaking to exclude some undesired code from the bundle. In this example, dev utils are only initialized for development builds, and we rely on tree shaking to exclude them from production builds. The tree shaking mechanism relies on constant values to decide about the dead code. And it is relatively easy to satisfy such a requirement at first when you're just developing the functionality and the condition is straightforward. But over time, conditions may stack up, the code gets moved around, refactored in a hurry, and actually before you know it, const get replaced with final because of some dynamic condition. And without any warning, development utils leak to production build, and nobody notices the problem until a few releases later. Actually, this is a very real issue that happened in our Flutter project. And this is where must use const annotation would come in handy. Let's start with its declaration. Here we have a Dart class called must use const with a const constructor and const instance of such a class. Also notice a target annotation above this class. It indicates what type of code elements can be annotated. In our case, it's a top-level variable. So it will automatically produce a warning if something unexpected is annotated instead. And here is an example of how it can be applied. At the very minimum, it reminds developers who come to maintain or refactor this code about the previous agreements, and hopefully it makes them pause and think about the reasons why this annotation is here. However, it would be even cooler if somehow we could automatically make sure that the top-level variable it annotates remains const. Developers still may forget about the requirements or get inattentive, but analyzer will not. And having a warning like this, it would definitely have helped us avoid the production issue in our code base back then. Well, in fact, in many cases, annotations have corresponding linter rules. Even override will not give you a warning without annotate overrides rule enabled. So now I'm going to show one of the ways to have custom code checks. I chose the path of building a custom analyzer plugin because it has the benefit of integrating your custom rules into the standard framework reporting mechanism, which means you get warnings right in your IDE the moment you introduce a problem, and also through the standard Dart analyze command. Here I prepared a very simplified, maybe not the most efficient example of how such a rule could be implemented with custom lint package, just to give you an idea. Here we declare a child of Dart lint rule and describe a warning it will issue. This top-level variable must use const. Then we subscribe to a callback that will be triggered every time the source code we are analyzing contains an annotated element. And inside the handler, we check if the annotated element is a top-level variable. And if it is, it is annotated with must use const annotation, but if it is not const, we issue a warning through the reporter. Although I made this example look very simple, the combination of annotations and custom linter rules is a rather advanced topic, but it can bring great benefits when working on the larger code bases, as it provides automated enforcement of best practices and following team-wide agreements, which is sustainable over time. If you're interested in more details about creating custom linter rules, I can recommend to check out this video. The API has changed since the time of recording, and most probably it will change again very soon. So be sure to also check the latest documentation for that. And I would also like to point out the role of annotations in code generation. We all are probably used to using JSON serializable package to help us with JSON deserialization of API responses, and are used to writing a code like this. Here we have a JSON serializable annotation. It is a critical part of the implementation without which the code will not be generated, but also it is a part of code documentation thanks to which we can understand what code will be generated without actually reading through it. And now if we look inside the implementation, once again, we see a plain Dart class with a const constructor and a few final fields. This time they configure the output of the code generator will produce. And the class is annotated with target kind class type, so this annotation can only be applied to classes. Two conclusions from this. First of all, once certain agreements in the project are established around how we do JSON deserialization, we tend to repeat the configuration over and over again. But remembering that annotations are just regular Dart classes that can be instantiated, we can create reusable instances of such annotations and apply them instead of copy-pasting the declaration and achieve exactly the same result. And second conclusion is that we can create custom annotations that will drive custom code generation. Well, actually, in this context, all annotations, including JSON serializable, freezed, injectable, route page, REST API, all of them are custom. So for this example, I'll demonstrate an annotation from my barrel files generator package. Without going into much details about the package and motivation behind it, there is an annotation called include in barrel file. It can be applied to all top-level elements like classes, enums, global variables, functions, extensions, so on. And after code generation with build runner is executed, those elements get collected in a single barrel file for the package. To achieve that, first I have declared an annotation class and an instance of it. And this once again is the simplified version of the code that collects all code elements annotated with this particular annotation. Then it gets the names of those elements and the name of the Dart library they are declared in, and combines them into a single export directive. And this is the method that produces the output code. This example is not full from the standpoint of creating a code generating package, but I hope it gives you the idea of how generators can rely on annotations and Analyzer API to parse your input Dart code and produce the generated output. If you'd like to learn more about creating a code generating package, check out this recording. And to sum up, today we have discussed what annotations are, how to create your own custom annotations, how you can leverage them in your projects. We have seen how they can serve as code documentation, help produce analyzer warnings with custom linter rules, and help configure code generators. And my hope is that after this session, you'll start looking at annotations not only just as something you have to use in your code base occasionally, but a tool that you actively leverage to make your code base more expressive, more maintainable, and reliable. And that's it for today. I'll be around after the talk, so don't hesitate to ask your questions. Thank you.